Hello, namaste, and good afternoon. Today we are going to study about a link state routing protocol. So in this routing protocol, we will learn about routing protocols and its concept. So in this chapter, we are going to describe the basic features and concept of link state routing protocols, list the benefits and requirements of link state routing protocols. As already told, we are going to learn about basic features and concept of link state routing protocols and the benefits and requirement of link state routing protocols. So link state routing protocol is also known as the shortest path first algorithms. This protocol is built around the Dijkstra SPF, shortest path first. So if we look about the classification of routing protocols, we can see the interior gateway routing protocols and exterior gateway routing protocols. And interior gateway routing protocols, there is a distance vector routing protocols and link state routing protocols. In a vector routing protocols, we can see RIP, IGRP, RIP version 2, EIGRP, and in IPv6 we have a RIP, ENG, and EIGRP for IPv6. Similarly, for the link state routing protocol, we can see OSPF version 2 ISIS and OSPF version 3 ISIS for IPv6. And for EGP, we can see classful as a EGP and BGP version 4 as a classless, while the IPv6 is BGP version 4 for IPv6. Dijkstra algorithm, also known as the shortest path first, SPF algorithm. And we can see here for the Dijkstra shortest path first algorithm, we can see that the shortest path for host R2 LAN. Okay, this is for R2 LAN to reach to host R3 LAN. So if you need to reach here from here to here, then we can calculate as R2 to R1 is 20, the cost of 20, let's suppose go 20. Then after R1 to R3, the cost is 5. Then R3 to LAN is cost 2. So if we add all this, then it will be 27. Okay. Similarly, the shortest path to destination is not necessarily the path with the least number of hops. So if there is a 1, 2, 3 hops, then it's not necessary that the shortest path will be the path with the least number of hops, but the shortest path will be the cost. If we add all the cost, then it will be the shortest path. So if we see here R1 to R3 has a least cost of 7. Similarly, R1 to R2 has a cost of 22. How the 22 has come from? It has came from 2 and 20. If we add up, then it will become a 22. Similarly, if R1, R3, R4, R5, then it will be 27. It will be R1, where's the R1, R3, R4, and R5. If we add all these, then it will be 27. Link state routing process. How routers using a link state routing protocols reach convergence. Each routers learn about its own directly connected networks. Okay, first the router learns about the directly connected networks, its own directly connected networks. It learns first. Then link state router exchange hello packet to meet others directly connected link state router. So then it will exchange a hello packet. And the third one is each router builds its own LSP, link state packet, which includes the information about its link. Example are neighbor ID, link type, and what the amount of bandwidth does it have. Okay, so in the third place, it will learn about its link. Okay, and fourth, after the LSP is created, the router forwards it to all neighbors, which then store the information and then forward it until all routers have the same information. Then after it building the LSP, it will flood that LSP to all the neighbor routers. And at feed point, once all the routers have received all the LSPs, the routers then construct a topological map of the network, which is used to determine the best routes in a destination. At last, the routing process is made, and in the routing processes, we can find the best routes to a destination. So if we look further, the directly connected networks, okay, for example, this R1, then R1's for this link Let's suppose serial interface 0/0, then it would have a link state of network, what the network it have, what is its IP addresses, what are the type of network, whether it is serial, point to point, like that, and the cost of the link, what is the cost of the link, and what is its neighbor. Let's suppose R1 has the neighbor R2 connected to the serial 0/0, then it will make its link state. Similarly, we can find the link state of R1 for the link 1. What kind of network it have, I mean what type of network is it, 10.1.0.0/16, what is the IP address configured in this interface, what is the type of network it has, like let's suppose it has Ethernet, fast Ethernet 0/0, what are the cost of that link, and what is the neighbor. If it does not have a neighbor, then it will say there is no any neighbor. So the link interface is an interface on a router. Okay, this is an interface on a router. This is the information about the state of the link. So what is the state? Is it Ethernet state, or is it a serial interface? What is the network it have? What are the neighbors it have? Similarly, sending a hello packets to our neighbors. Okay, how does the hello packets are sent from a router to its neighbor? Linked routing protocols use a hello protocol, and what's the purpose of hello protocol is to discover neighbors. Okay, this has to discover this neighbor, and this has to discover its neighbor. So to discover that, use the same link state routing protocol on its link. Okay, first router learns about its directly connected networks. Each router is responsible saying hello to its neighbor on a directly connected network. So example, this will say hello to this will say hello to this, and this will say hello to its own LAN network. Link state routing, sending hello packets to neighbors. Okay, as we have discussed earlier, that this R1 say hello to R2, and R1 again say hello to R3, similarly to R4. Then R2 will respond with its hello, saying hello R1, I am R2, hello R1, I am R3. Similarly, like this, they will exchange a hello packet. Sending hello packets to a neighbor connected interface that are using the same link state routing protocols will exchange hello packet. As already said, this will say hello, then as in turns it will also say hello to R1. Once the router launch, it has a neighbors, they form an adjacency. Okay, now after the hello packets exchange, they will form an adjacency. Two adjacent neighbor will exchange hello packets. Okay, this and this will exchange hello packets. Similarly, these two will exchange hello packets. This packet will serve as a keep alive function. Okay, this is alive. Okay, I'm alive, I'm here. It will say like that. Building a link state packet. Okay, each router builds its own LSP. Okay, this will builds on LSP, this will build on LSP. So what does the LSP have? Content of each directly connected networks. So it will have a state of each directly connected network, includes the information about neighbors such as neighbor ID, link type, and bandwidth. As discussed earlier, it will have what kind of network it will have, what kind of cost it will have, what kind of interface does it have. It is a point-to-point interface, either it is Ethernet or serial interface. So it will be like that. Flooding LSP to neighbor. Okay, the maybe this is the fourth point. How does the flooding takes place to the neighbors from router R1 to R2? Let's suppose once LSP are created, they are forwarded out to neighbors. Okay, this is forwarded to a neighbor. After receiving the LSP, the neighbor continues to forward it throughout the routing area. So this will forward to this, and this will forward, flood, and so until and unless all the routers will have the same LSPs, they will forward the packet to each and every neighbors. LSP are sent out under the following condition. Initial router startup or routing process, when the initial router will start, and when there is a change in topology. For example, if this network is cut off from here, then this will again send the LSPs to all the routers, so that the latest routing table will be available on all the routers. Routers use the database to construct a topology map of the network. So okay, how does the LSDB is formed? LSDB is formed by constructing a topology map of the network. Each router uses the database to construct the complete map of the topology and computes the best path to each destination network. Okay, this is the for the link state routing process. So if we take a look at here, then how the linked state routing process is formed is through R1 link database, R1 link state database SPS from L2, sorry R2. Okay, from R2, if we check out from here, connected to the neighbor R1 on the network 10.2.0/16, it has cost of 20. Similarly, connected to the neighbor R5, it has R5, and it has a network of something XXX and cost of 10, and also has a network of 10.0.5.0 of cost 2. Similarly, the LSP of R3, R4, R5, and R1 link. Okay, for this also it will have a LSP. Shortest path first, SPF tree. Building a portion of the SPF tree, process begins by examining R2 LSP information. R1 ignores first LSP, and the reason is R1 already knows it's connected to R2. So this one is already connected to R2, so it will ignore its first LSP. So R1 will have a link state. Similarly, R1 uses a second LSP. Okay, the R1 will use the second LSP. Reason R1 can create a link from R2 to R5. Okay, from here to here, it will create a link. This information is added to R1 SPF. So this will add it to the R1 SPF. R1 learns that R2 is connected to 10.5.0. Okay, this will launch that it's connected to 10.5. Let's find 10.5 is here. This link is added to R1's SPF tree. So this will be added to SPF tree. Determining the shortest path. The shortest path to destination determined by adding the cost and finding the lowest cost. Okay. So the lower the cost, the shortest the path to destination. Once the SPF algorithm has determined the shortest path routes, these routes are placed on the routing table. So the routing table will have routes which have shortest cost, shortest path or the lowest cost. Okay, as you can see here, the SPF algorithm R1, it will calculate all the networks cost, and at last it will keep the shortest one is 7, 10.0.6.0. Okay. So if we look at the advantage of linked state routing protocol, then over a distance vector protocol, then we can see here the builds a topological map. Yes, it will first build topological map, while the distance vector does not build a topological map. Similarly, router can independently determine the shortest path to every network. Yes, it will make a shortest path to every network, whereas the distance vector does not. The convergence is really fast, so link state, more preferably ISIS, will be used by a large ISPs or service provider because the convergence is really fast. A periodic event-driven routing updates. Yeah, it will send the routing updates of whether there is any changes on the routing or not. So, okay, so the uses of LSP is there in the link system routing. So if we check out the requirements for using a linked state routing protocol, then there is a high memory requirement. Typical linked state routing protocol use more memory. Okay, it will use the more random access memory. Similarly, the processing requirement is also high. More CPU processing is required of linked state routing protocols, and the bandwidth requirement is also high. Initial start of linked state routing protocols can consume lots of bandwidth. Okay, two linked state routing protocols used for routing IP. One is OSPF and another is ISIS, which is intermediate system to intermediate system. So if you look at here, OSPF version 2, OSPF for IPv4 network RFC 1247 and RFC 2328. Similarly, for OSPF version 3, we can find that in RFC 2740, the OSPF for IPv6 network. Similarly, in IPv4 OSPF version 2 will be discussed more in the subsequent chapter. ISIS is the ISO 10589, an integrated ISIS. Dual ISIS supports IP networks used mainly on ISP and carriers, and this will be discussed more further in other chapter as well. So if we look at the summary, linked state routing protocols are also known as shortest path first protocols. Summarizing the linked state process, router first launch directly connected networks. Routers then say hello to neighbors. Routers then build a linked state packets. Routers then flood LSP to all neighbors. Routers use LSP database to build a network topology map and calculate the best path to its destination. Okay? Plus the base path destination is created and the routing table is created as well, constructed. So link, what is link? Link an interface on the router, where the link state is information of IP addresses, subnet marks, type of network, cost associated with the link, neighboring routers on the link. After initial flooding, additional LSP are sent out when a change in topology occurs. So link state is updated when there is a changes in the topology. Okay, example of link state routing protocol are OSPF and ISS. Thank you very much for your time. Hope this chapter or lecture has been very informative to you. I hope you find this lecture interesting one. Thank you for your time, and I would like to request you to subscribe my channel and hit a like button. And again, thank you for your time.